Hi guys, I trust that you're feeling well and awesome. Welcome to this video on grade 12 mathematics, and in this video, we'll be having a look at differential calculus under the subtopic laws of differentiation. This is a continuation of the videos that we uploaded yesterday and the third video in our series of videos covering differential calculus. If you have not watched the previous two videos, I would highly suggest that you watch them so that you can have a good overview of what exactly differential calculus is, what the first principles is, and how to do the differentiation, the purpose behind it. In today's lesson, we'll be focusing on the laws of differentiation. So without any further ado, let's get straight into it. If we have a function f of x is equals to ax to the power n, we can easily find the derivative by multiplying the exponent by the coefficient and then subtracting 1 from the exponent. Let's have a look at an example of exactly what this means. So over here, we've got a function f of x is equals to 3x squared minus 1. We can calculate f of x plus h by saying this is equals to 3 into, where we see x, we substitute x plus h, squared minus 1. This is going to give us 3 into x squared plus 2xh plus h squared minus 1. Then we multiply out the 3. 3 times x squared, that's 3x squared. 3 times 2xh, that's going to give us 6xh. 3 times h squared, that's going to give us 3h squared minus 1. There we have it. We have an expression for f of x plus h. Now we need to substitute this into our formula for the first derivative. We said that f prime of h is given by the limit as h approaches 0 of f of x plus h minus f of x divided by h. Now we just substitute what we know. So we keep the limit sign until we substitute h is equals to 0. F of x plus h is 3x squared plus 6xh plus 3h squared minus 1. Minus f of x, which is provided up here, that's going to be 3x squared minus 1. And all of this is going to be divided by h. Now we simplify. This is going to be the limit as h approaches 0 of 3x squared plus 6xh plus 3h squared minus 1 minus 3x squared plus 1 divided by the h. Now, when you get to this point, and if everything is done correctly, the terms that do not contain h as a coefficient will cancel out. Now, 3x squared minus 3x squared, that cancels out. Minus 1 and positive 1, that cancels out. We remain with the limit as h approaches 0 of 6xh plus 3h squared divided by h. When we get to this point, we can take out a common factor. So let's bring down the limit sign. Our common factor in this case is h. Now, wait a minute. Some of you might be saying, no, our common factor is 3h, which is absolutely fine and 110% correct. However, due to the fact that I want to cancel out my denominator, taking out h, which is the same as my denominator, is sufficient. I'm going to have 6x plus 3h divided by h. The h and h will cancel out. I'm going to remain with the limit as h approaches 0 of 6x plus 3h. Now what we can do is, because our denominator of h is gone, we could substitute h is equals to 0, get rid of the limit sign. 6 plus 3 into 0, this is just going to give us 6x. And there we have it. Life is great. When we look at our expression, we've got 3x squared minus 1. So let's look at this. We are saying f of x is equals to 3x squared minus 1. Let's look at our laws of differentiation again and see how we could do this without the necessity of us having to multiply and having to go through this process of the first principles. So we said we can multiply exponent by a coefficient, then subtract 1 from exponent. Let's look at our second law. The derivative of a constant is 0. So what does this symbol mean? This basically means the derivative. And you'll have different symbols that mean the same thing. You could have dy over dx, This is the same as saying y prime, which is the same as f prime of x or g prime of x, which is the same as just putting in dx. All of these mean the same thing. They imply that you need to find the derivative. So when you see these symbols, do not be confused, do not get surprised. They all mean the same thing. Find the derivative. So the derivative is a constant. This is something we just need to know. Right. The derivative of f of x plus the derivative of g of x is equals to the derivative of f of x plus g of x. What are we saying here? The sum of derivatives is equals to the derivatives of sums. Let's get back to our example so that we can actually employ what we've learned so far. So, when we look at this, f of x is equals to 3x squared. To find f prime of x, I can basically take the derivative of 3x squared minus the derivative of 1. Now, the derivative of 3x squared, we said we multiply exponent by coefficient. 3 times 2 gives us 6x. Subtract 1 from the coefficient, we just remain with x to the power 1. Minus 1 is a constant. The derivative of a constant we said is 0. So we could get our derivative as just 6x. Notice that this is exactly the same answer that we got in our first process where we were using the first derivative. However, we got the answer without the necessity of having to write out the entire steps. Life is great. Take note of something. In your exam, there's going to be one question where you have to use the first principles, like what we did at the start of the video. All of this. The rest of the questions where you'll be using laws of differentiation, it's okay to use what you've seen right now, where we multiply exponent by coefficient and subtract 1 from exponent. This is what we call the power rule. So, f prime of x, we're saying is equals to n times ax to the power n minus 1. This is what we call the power rule. And it's basically a shortcut for us to use whenever we are finding the derivative. Nevertheless, let's get back to our notes. So we said that the sum of derivatives is the derivative of sums. Then the difference of the derivatives is also equals to the derivative of the differences. Take note of something. Division and multiplication are two different steps. If I find the derivative of f of x divided by the derivative of g of x, this is actually not equals to the derivative of f of x divided by g of x. The product of the derivative of f of x and g of x is not the same as the derivative of f of x times g of x. Please take note of this. In the event that you do come across such a question, you would just need to simplify, factorize, and most importantly, when it comes to differentiation, your laws of exponents really come in handy. Laws of exponents and surds, you are required to know and master these in order for you to be able to succeed in differential calculus. If you still have a problem with the laws of exponents and surds, you can check out our video on grade 11 exponents and surds, which I will link the description. I'll link it down in the description below so that you can have a refresher on how to apply the laws of exponents. Nevertheless, let's solidify our understanding by doing some examples. So the first question says we are finding the derivative of x cubed minus 3x squared plus 6x minus 4. Now, let's go to the writing pad and let's attempt this one. So, we have got d over dx, which I said to you means find the derivative of x cubed minus 3x squared plus 6x minus 4. According to our laws of differentiation, what we need to do is we need to find the derivative of x cubed, derivative of 3x squared, derivative of 6x, derivative of negative 4. To get the derivative of of x cubed, we multiply the exponent by the coefficient. Our coefficient is 1 here. 3 times 1 gives us 3x. When we subtract 1 from exponent, we get 2. Wonderful. We go to negative 3x squared. Multiply exponent by coefficient. 2 times negative 3, that's going to give us negative 6x. Subtract 1 from exponent. We move on to the positive 6. Our exponent is 1 here. 1 times 6, that's just going to give us 6. x. Subtract 1 from exponent, this is x to the power 0. We move on to negative 4. Negative 4 is a constant. We said the derivative of a constant will always be 0. Life is great. Now we simplify what we have. This is going to be 3x squared minus 6x plus 6. And there you have it, you found the derivative. Life is great. I hope that this made sense to you guys. Let's look at the next question. So the next question says we need to find the derivative of x squared minus 5x plus 4 over x minus 1. Let's look at this one. So we are given the derivative of x squared minus 5x plus 4 divided by x minus 1. Please take note, according to our laws of differentiation, it would not make sense for you to find the derivative of the numerator divided by the derivative of the denominator. Our laws of differentiation says that is not allowed. So what do? Well, this is what we can do. Let's keep the dx sign here because we're not yet finding the derivative, we're just still simplifying. We can factorize the expression on the numerator because that's a trinomial, divided by x minus 1. This is x, this is x. This is 4, this is 1. This is minus, this is minus. X minus 1 will cancel x minus 1. What do we remain with? We simply just remain with x minus 4. Now we can find the derivative. So the derivative of x, this is to the power 1. Multiply exponent by coefficient, which is 1. We just get 1. X. Subtract 1 from exponent, this is 0. The derivative of negative 4, which is a constant, will just be 0. Your answer will just be 1 because x to the power 0 gives you 1. So the derivative of this expression is just 1. Brilliant. Life is great. Let's look at the next question. This is an interesting one. We've got 1 minus 4 divided by the fourth root of x. Let's have a look at this one. Let's scroll down for some room. We've got 1 minus 4 over the fourth root of x. Now, when you're given a question like this, the first thing that you need to make sure of, as I've mentioned earlier, is that you express your surds in exponential form. We need to remember laws of exponents. This is going to be 1 minus 4 over x to the power 1 over 4. If you can remember from your laws of exponents, we could take this to the top. So we're going to have 1 minus 4x to the power negative 1 over 4. Now, for us to find the derivative here, we will say, what is the derivative of 1? Well, 1 is a constant, so the derivative is 0. Then we get to negative 4x to the power negative 1 over 4. Multiply exponent by coefficient. Negative 1 over 4 times negative 4 will give us positive 1. So this is just x. Subtract 1 from exponent. Negative 1 over 4 minus 1 will give you negative 5 over 4. We are dealing with negative exponents here. So we remember that when we're dealing with negative exponents, we need to swap numerator and denominator. This is x to the power 5 over 4. Now, when we get to this point, we could simply write this as 1 divided by the fourth root of x to the power 5. This would be our derivative. Wonderful. Life is great. Let's look at the next question. So, in our next question, we have something which looks a bit messy, but is very much interesting. Let's have a look at this question. So, let's just copy it down. Open up a new sheet for some more room. We are given dx of, let's see. So this is dx of the cube root of x to the power 5 minus 5 square root of x plus 4 fifth root of x to the power 7. And all of this is divided by the square root of x. This is an interesting one. So the first thing we need to do is we always need to write our surds in exponential form. This is going to be x to the power 5 over 3 minus 5x to the power a half plus 4 x to the power 7 over 5. And all of this is divided by x to the power a half. Now, when you get to this point, what you can do is you can write each one of your numerators with the same denominator. So this is dx into x to the power 5 over 3 minus x to the power a half minus 5x to the power 1 over 2 divided by x to the power 1 over 2 plus 4x to the power 7 over 5 divided by x to the power 1 over 2. Let's simplify this. This is going to be dx into, this is x to the power 5 over 3 minus 1 over 2. Because when we divide numbers of the same base, we subtract the exponents. These two will cancel out, we just remain with minus 5. Then this is going to be positive 4x to the power 7 over 5 minus 1 over 2. Now we can simplify. This is dx of, let's see, x to the power 5 over 3 minus a half. So that is going to be something like, let's see, we need to find an LCD, which is 6. 3 goes into 6 twice, 2 times 5 is 10. 2 goes into 6 3 times, 3 times 1 is 3. Minus 5 plus 4x into, our LCD is 10 here, so 5 goes into 10. Twice, 2 times 7 is 14. 2 goes into 2 goes into 10, 5 times 1, that's going to be 5. You could use a calculator to subtract the fractions. I do not have a calculator on me, hence I am using the long technique. So this is going to give you x to the power 7 over 6 minus 5 plus 4x. Let's see, 14 minus 5, that's going to give us 9 over 10. Now take note, we have not yet found the derivative, we just simplified everything. Now we can find our derivative. Multiply exponent by coefficient. This is going to be 7 over 6x to the power, subtract 1 from the exponent, that's going to give you 1 over 6. Derivative of minus 5, that's going to be 0. Multiply exponent by coefficient. So let's see, if we have 9 over 10, multiply by 4. So 2 goes into 2 twice, 2 goes into 10 5 times. So you're going to get 18 over 5 here. So this is positive 18 over 5. X to the power negative, when we subtract 1, we're going to get negative 1 over 10. Now to write our answers back in surd form, this is 7 over the 6th root of x. 0 goes away, plus, I made a little bit of a mistake. This is just supposed to be 7 6th root of x because we do not have a negative exponent. Then we've got positive 18 over, we've got a negative exponent here. So this is 5 10th root of x. I hope that this made sense to you guys, and I hope that you enjoyed it, that you understand the concept of how to find the derivative using the laws of differentiation. Please give us a like, please give us a thumbs up if you liked the video. Please subscribe to the channel, click on the bell icon so that you will always receive an update every time we upload a new video. Most importantly, please share the video with other people so that everybody can be benefiting from the knowledge that you're learning. Until we meet again, enjoy the rest of your day. Ciao.